Hello everyone, I am Shongita Burkait, Assistant Professor of Swami Vivekananda Institute of Science and Technology. Today I am going to discuss about a topic L hospital rule. Actually, L hospital rule depends with indeterminate form. If we have any type of indeterminate form, then we apply L hospital rule. Now, what are the indeterminate form? Generally, a function is said to assume indeterminate form when it takes up any one of the following forms. Number 1, 0 by 0. Number 2, infinite by infinite. Number 3, infinite minus infinite. And number 4, 0 into infinite. Number 5, 0 to the power 0, 1 to the power infinite, infinite to the power 0, etc. If we have any one of this total type of indeterminate form, then we apply L hospital rule or L hospital law. Actually, if we don't get any type of indeterminate form, then we don't need to apply L hospital law. Okay, L hospital law actually using to solve this type of indeterminate form. Now, how to solve this L hospital law? Before going to this portion or before going to this topic, we have to know what is L hospital theorem. Okay, now statement of L hospital theorem is, if there is any two type of function f and g, obviously they are function of x and function of g of x, that is f and g both are function of x. Okay, now the condition number 1 is this both function fx and gx have to continuous in the closed interval ab. Number 2, fx and gx both are derivable in the open interval ab. And number 3, limit extends to a plus f of x and limit extends to a plus g of x will be 0, where a is any point which must be positive. This plus indicates the positive number. And if fx and gx satisfy all of these three conditions, then the L hospital theorem is limit extends to a plus f of x by g of x will be limit extends to a plus f dash x by g dash x. This f dash x means the derivative of fx and this g dash x means the derivative of g of x. Now, from this last line of L hospital theorem, we can see that the form of the L hospital theorem is some function divided by some function and their limiting value. That is, if two functions are in a numerator by denominator form, then for finding their limiting value, if there is any type of indeterminate form arise. Now, what are the indeterminate form? We already discussed in our first slide. So if any type of indeterminate form arise, then these two function, if the two function satisfies all these three conditions, then L hospital law or L hospital theorem states that we can derivative both our function fx and gx simultaneously. Okay, now if we see in our first slide, there is numerator by denominator indeterminate form is only one, actually only two, that are 0 by 0, 0 by 0 and infinite by infinite. Okay, these two are the numerator by denominator form function. Okay, suppose, but if we have any other type of indeterminate form like infinite to the power 0 or 1 to the power infinite, okay, if we have this type of indeterminate form, and you can see that this type of indeterminate form is not in a form of numerator by denominator. So what we have to do, we will change this indeterminate form in any one of these two numerator by denominator indeterminate form, and then we apply this L-Hospital law. Because L-Hospital law or L-Hospital theorem, we can say that, or we can see that here there is two types of function, fx and gx, and they are in numerator by denominator form. Okay, now let us discuss some example on L-Hospital rule. Find limit x tends to 0, 1 by x minus 1 by e to the power x minus 1. See, if we put x equal to 0 here, we get 1 by 0, which is infinite, minus 1 by e to the power 0 is 1. So 1 by 1 minus 1, that also be 0. So 1 by 0 will be infinite. So our indeterminate form in first line, we can get that our indeterminate form is infinite minus infinite. But this indeterminate form is not in a numerator by denominator form. I have already said that L-Hospital theorem, we can apply L-Hospital theorem only when our function is in numerator by denominator form. So we have to change this infinite minus infinite indeterminate form in 0 by 0 indeterminate form or infinite by infinite indeterminate form, because these two are only numerator by denominator indeterminate form. So if we calculate our first function or our main function, if we calculate this, then we can get e to the power x minus 1 minus x divided by x into e to the power x minus 1. Okay. Now, if we put x here in the second line, if we put x equal to 0 here, we can get e to the power 0 is 1 minus 0 minus 1. So that will be 0. And in denominator, if we put x equal to 0 here, so we can get 0 into e to the power 0 minus 1. So that will also be 0. So our indeterminate form infinite minus infinite change into numerator by denominator indeterminate form. Now after this line we can apply L-Hospital theorem. And what was in our L-Hospital theorem? We derivative both our numerator and denominator. Now in our numerator there is e to the power x minus 1. So derivative will be e to the power x, derivative e to the power x minus derivative of x is 1 and derivative of 1 is 0. Now in denominator there is x into e to the power x minus 1. So we can apply here the derivative of product rule, that is if we take x is u and e to the power x minus 1 is v, so derivative of uv, we know that u into derivative of v plus v into derivative of u. So according to this we get e to the power x plus x into e to the power x minus 1. Now again if we put x equal to 0 here, we get again 0 by 0 indeterminate form. So since indeterminate form arise again, so we have to derivative again our numerator and denominator. Now in our numerator it is e to the power x minus 1. So by derivative we can get e to the power x. Now in denominator there is e to the power x whose derivative is again e to the power x, and x into e to the power x derivative we can apply here again u into v product rule of derivative. So after applying this we can get 2 into e to the power x plus x into e to the power x. Now again we put x equal to 0 here, and we can get e to the power 0 is 1, and 2 into e to the power 0 is again 1 plus x into 0 into e to the power 0 is 1. Now you can see that in this line there is no indeterminate form. Indeterminate form vanish from this line, so we erase our limiting value, which is write the number which is 1 by 2. So this is our final answer. So if we in this way we can calculate all the examples of L'Hospital rule. So we have to first calculate the main indeterminate form. Then if we see that if it is not numerator by denominator form, so by calculating we first change the indeterminate form in numerator by denominator form. Then we apply L'Hospital rule, which is we derivative both our numerator by denominator up to when the indeterminate form vanishes. And if indeterminate form vanishes, then we get a finite number, which always be the result of L'Hospital rule. So in our L'Hospital rule we can get always a finite number as an answer. Okay. Now let us discuss another example which is very important. This is another type of example. Now if the question is, if x tends to 0, sine 2x plus a sine x by x cube be finite, find the value of the constant a. This a is in this a and the value of the limit. Now you can see that if we put x equal to 0 in our numerator, we get sine 0 is 0 plus a into sine 0 0, and in denominator there is x cube, so it is also 0. So we can directly get the numerator by denominator indeterminate form, which is 0 by 0. So we can apply L'Hospital law from our second line. So we derivative both our numerator and denominator. So derivative of sine 2x is 2 cos 2x plus a into sine x derivative cos x, and derivative of x cube is 3x square. Now again we put x equal to 0 here, and we can see that now in this second line if we put x equal to 0 here, you can see that we get 2 into cos 0 1, that is it is 2 plus a into cos 0 1, it is small a, divided by 3x square, that is 0. Okay, now you can see that our numerator is 2 plus a and denominator is 0. So it is not indeterminate form, but in our question paper here it is given that the limiting value will be finite, and I already told you that we can get the result of L'Hospital law, which always be finite after applying L'Hospital law. Okay, but in this second line there is no indeterminate form. Numerator is 2 plus a, denominator is 0. So if there is no indeterminate form, so we can't apply L'Hospital law. So for applying L'Hospital law, we have to check, we have to put this constant a as -2. You can see that if we put small a, the constant is -2, so our numerator will also be 0. So we can get our indeterminate form 0 by 0. And if it is 0 by 0, so we can apply L'Hospital law, and last we will get our finite value. Now, hence, in order that the limiting value of the expansion may be finite, so the numerator 2 plus 2 cos 2x plus a cos x should must be 0. Okay, this gives 2 plus a equal to 0, that is a equal to minus 2. Okay, now when a equal to minus 2, we derive the limit again from this line. From this line, we derive the limit again. That will be limit x tends to 0, 2 cos 2x plus, in place of a, we put minus 2 into cos x by 3x square. Now, if we put x equal to 0 here, you can check that that will be again our indeterminate form 0 by 0. And since it is 0 by 0, so in next line we apply L'Hospital theorem, which is we derivative both our numerator and denominator. So by derivating both our numerator and denominator, we can get minus 4 sine 2x plus 2 sine x divided by derivative of 3x square will be 6x. Again we put x equal to 0 here, and we can get 0 by 0 form again. So we have to again derivative both our numerator by denominator. So that will be minus 8 cos 2x plus 2 cos x divided by derivative of 6x is 6. Now again, now if we put x equal to 0 now, then we can get minus 8 plus cos 0 1 plus 2 into cos 0 1 divided by 6. Now in this line, you can see that there is no indeterminate form, so we just erase this limiting value, just write the number which is equal to minus 1, and this is a finite number which was in our question paper, that the limiting value will be finite. So, and if we put a equal to minus 2, then only we get the limiting expansion is minus 1. So for our calculation, or for our betterment of calculation, we have to prove, we have to put this constant a equal to minus 2 and rewrite the value of a in our limit, and we can apply the L'Hospital law and finally get the limiting value as minus 1. So that was the L'Hospital theorem or L'Hospital rule. In this way, you can apply L'Hospital law if we faces, or if there is arise any type of indeterminate form, so we can apply L'Hospital law. So mind it, we have to first change our indeterminate form in numerator by denominator form, and then we can apply L'Hospital theorem. So uh, that was the final result. I think that will be very much helpful for you. So thank you.